I've been working on rebuilding this old Jeep and doing some other projects that require a bunch of custom fabrication. If there's one thing I've learned from watching YouTube, it's that custom fabrication is really just a fancy way of saying making brackets. And making brackets is really just the practice of making the wrong bracket first. Sometimes several of the wrong bracket. I'm thinking that a small CNC plasma cutter would really speed up the process of making the wrong brackets. I don't have a lot of space, and I looked at some of the small commercial units, but it turns out they usually want money for those. And I've probably got enough naive lack of foresight and random junk laying around here that I can just build my own from scratch. So let's build a bracket robot. I've got this strange sort of mini I-beam that should make a pretty good backbone for it. I picked up some cheap linear rails. Viver had these on closeout for like 40 bucks. At that price, we'll find out if you can go wrong or not. Obviously, it's a little too long, but that's why we have... Oh yeah, those are hard. Okay. Guess it's not a surprise, but this thing is not flat at all. Got the part that I just milled up on some blocks here. Since this end is still rough, I'm going to use an adjustable parallel under here. Machining something like this that's longer than the mill travel is an exercise in flipping the part, moving it, trying to reference and indicate off the newly machined surfaces. If you take your time, you can get things lined up pretty well, or at least well enough. These rails require a lot of mounting holes, and the spacing is metric, which just adds to the challenge on an Imperial machine with no DRO. But the real hero of this project is the tapping head. Since all of these holes were drilled in one setup, I think we can agree that those are all in a straight line. But since I'm only referencing off of a very short section of irregular material, they aren't necessarily in line with what's on here now. So I think the best thing to do is to center punch them and go off that. So I've got this centered up on the rail. So now if I clamp this rail in the vise, the holes I put in here will be centered up off of that rail. And then it's just more of the same. Before I work out the little carriage part, I want to work out how I'm going to drive this thing. I've got this old lathe lead screw that I think will work. I want to get this mounted so I know how high up to make the carriage. If I can extend the threads on here, I'll probably get a little over 30 inches of travel. The story behind this is a friend of mine had me pick up this lathe for him as a parts machine. It had been a parts machine for somebody else previously. He took the parts he needed and left me with the rest of it, so I might as well repurpose some of it. Of course, before I thread the lead screw, I should make the nut so I have something to test the thread against. I've got this little chunk of Teflon I'm going to make it out of. This is sort of an experiment. I have no idea how it'll hold up long term, but I had this, so I figured I'd give it a try and see. I can always make one out of bronze in the future. So this is too big a diameter to fit through the spindle on my lathe, and it's too long to use my tailstock. So I've got my steady rest set up. This one always gets a lot of comments from people that are new at the channel. I'll leave a link to the video up there. Because I have it on the steady rest, I have to have my nut already threaded on here. And because of the keyway and the threads, I had to turn a little collar for this. Kind of shrunk fitted on there, and I'll just take the grinder and knock it off in the keyway, and then should be able to get it off that way later. So now it's just a matter of picking up that thread and doing the usual. Definitely fighting chatter a little bit, so running really slow. That took quite a bit of tweaking things around to get that thread to match up as well as I could, but I think it came out pretty well. It's actually kind of even hard to tell where it lines up. I did check over pins a little bit, and one of the problems is it's hard to tell if you're supposed to be matching it to the worn part or to, say, the other end where it's not as worn, but it was a good bit of effort, but I think it'll work out pretty well. It probably would have been easier for me to just make the whole lead screw from scratch, or even easier, just buy a piece of Acme thread. But that's not the point of these builds. It's not about doing it the easy way. It's about making something that makes you question how you look at, what might be considered trash or scrap, or see if it's something you can salvage and repurpose and look at it a little differently. Of course, having said that, I bought a brand new stepper motor, and I need to attach these two together. This is usually where someone in the comments section says I should just go on McMaster and buy a Lovejoy connector, and usually they suggest that for the wrong application, like the adapter plate I made for the motor on my Jeep or the spline coupler I made for that well pump. But in this case, this is the proper application for a Lovejoy connector, and I can get one that mounts directly on the stepper and mounts directly on the lead screw. I did have to cut the little threaded nub off there. I think that the keyway in this is actually even the right size for this Woodruff key. The proper time to use a Lovejoy connector is when you have a low torque application with slight misalignment, and especially if you're joining together two different size shafts. This one's 10 millimeters, and this is 9/16 of an inch. So, that's super easy. Now I just need to make a mount for this. I started drilling the mounting hole here and went just far enough to screw things up before I realized that that's going to break through into this bore and will interfere with the coupler in there. So I think I can still save this. So I also made a little bronze bushing for the lead screw to ride on, and while I was at it, I made a shaft collar here. That way I can adjust the end play on it. Put an oiler in there. These holes are just here so that I can tighten the set screw on the coupler. I had to mill out a little bit on the bottom of the I-beam to fit this down in there. I also made a similar sort of block and shaft collar for the other end. And on this end, I've got the pattern for a NEMA 23 motor. Problem is, this is a NEMA 24 motor, which means that these holes are 3 millimeters further apart than what I did. My local hardware store actually had some aluminum screws. Throw a little Loctite on there. I thought I had some red, but we'll use green. I definitely created a little extra work for myself there, but that's how you move a bolt pattern, and I think we can move on and never talk about that again. With having a slit through here and threads in the bottom, I can basically crank down on those screws, tighten this down, and adjust the amount of backlash on this. Despite my best efforts, the top of the nut ended up just a little too high, but that's not too hard to fix. I've got a crusty piece of C-channel that should work well for the Y-axis. That got basically the same treatment mounting the rails as the other one. To drive this, I'm going to pirate the rack from the hand wheel from this lathe, which is easier said than done. You might be wondering why I didn't just use the bed and carriage from the lathe. That's because the carriage is one of the parts that already got pirated from this, and the bed looks like it was lubricated with sand. I had to drill out the final screw, and strangely enough, it was only finger tight once I got it out. Of course, each of these screws had to get cut down to length. I feel like it's a pretty well-known trick, but if you drill and tap a piece of stock, you can get a pretty consistent length without buggering up the threads on the ends. A whole bunch more drilling, counterboring, tapping. I have another one of these done on here, so slidey bit's good to go. I don't really want this to run off the end and spill the ball bearings everywhere, so I'm going to put a little roll pin in as a stop. The other end got one as well. I pirated a bunch of gears out of the gearbox from the lathe. I'm thinking I can take this cluster gear, put that there, and use this one on the motor. Something like that. That should give me a good gear reduction so I don't have to micro-step the motor too much. This next part took a lot more head scratching and sloppy machining than it probably should have. The inherent problem with using a spur gear like this and a rack, especially one that's worn, is there needs to be some amount of clearance between them or it binds up, so you end up with backlash. So when the motor changes direction, there's going to be a little bit that the motor's moving one way, but the carriage doesn't move at all. I can compensate for that in the software, but I still want to minimize the amount of backlash. So I put some little slots in here so this can slide back and forth a little bit. The problem with that is this rack has some wear on it, and obviously this isn't perfectly straight. So when it's tight in one spot, it's still got some backlash in others. So if we let this part float a little bit, and add in a spring, and a screw just to keep the spring from going sprawling, now we've got something that has pretty minimal backlash. Can move back and forth pretty freely, and will self-adjust based on the wear on the rack. And the stepper motor also got little slots for it, and some little captive nuts that can slide back and forth. Of course, I reused a piece that already had some holes in it, and that hole landed right where there's a countersink already. But since I dropped the motor and broke out the mounting hole in the motor, we're just going to pretend that I don't need that one. I think the next thing to do is to make a stand for this so I can take it out of that vise. I'm going to start at the bottom and work up. I got some crusty casters that were a viewer gift. That is not. And some crusty metal plates. You know what would make this a lot easier? CNC Plasma Table. I've got some parts from the treadmill frame. This stuff is usually pretty thin wall tube, but it should be just fine for this application. I stripped down the main beam of this thing and made up some little plates that pick up some of these existing holes. On this end there are 4 holes that were tapped M6. On this end there are 2 that are M10. There weren't any on the back, so I added 3 M8 holes to keep it consistent. I want to see how much spring back I'm going to get when I take this jack out. Oh, about none. It's not even sitting on the jack. Well, that's starting to look like something. Let's see if we can make it do something too. As daunting as that seemed, it really wasn't too bad. I've got a power supply here, I've got my stepper drives here. The 2 that are on the machine now are here, and then for the Z-axis, I haven't done that yet, but I have a smaller stepper. Figure to keep the mass down, and a smaller drive for that. I kept the step and direction wiring consistent for all 3 of them. That way if the pattern's wrong, it makes it easy to see. I'm also lacking a 5-volt source for my Mesa card right now. I'll go ahead and order one that'll just feed off this power supply. But for now, I'm just using a USB cable. I bought a surface plate at a machine shop auction a few years back. It was sort of one of those everything in this corner of the shop is one lot. Came with this early 2000s Dell computer. I think it's a Pentium 4. It's not going to be the ideal machine for running a CNC, but it does have the appropriate amount of grease already on it. It also didn't have a working monitor with it, but the junk man down the road had this old TV with a VGA input for free $95. If I can use this stuff instead of turning it into e-waste, I think that's a win. Managed to get Linux CNC installed on here. Let's see if we can get this thing running. Well, it took me most of the day of troubleshooting, but finally got that moving. I know there are machine torches available, and there's also someone who designed a 3D printed conversion for this torch to turn it into a machine torch. But hey, I gotta leave room for future upgrades, right? So this has a little bit of a taper to it. It looks like it's about 25 thousandths per inch on each side. And it's also a little bit wider this way than it is this way, which will make it clamp down in there really nice. Since I just updated the Dr. DRO electronic lead screw, it should be a little easier to do the ratios. We'll do 1,000. We want 25 on each side. Actually, that was backwards. Swap that. Now when I move this, I did a previous video on this system and how it works for cutting tapers. You should check that out if you have questions. I haven't figured out how to exactly hit a dimension with this, but I think that's going to be pretty close. Well, that's not looking right, because that is the wrong shell mill. That's okay, I'm going to have some blending to do anyway on this. I'd say that's pretty darn close right off the machine. Need to open it up a little right there. That's extremely satisfying. Now that needs to go on there and go up and down. Since I've got a bunch of this rail left over, I found some more of those slide blocks that were pretty cheap, and the stepper motor, and that, and this old lead screw that a viewer gave to me. This hand wheel's pinned on. Looks like it's a straight pin. Took a bit of heat to get it to loosen up. There's also no hole through there to drive the shaft out. There we go. The nut for this thing isn't in bad shape, other than the fact that that's all I have for a reference surface. We'll assume that that is perpendicular to those threads. I came up with 1'380", so take away half the diameter of this. I came out 1'130". That should put that surface right against the vise. Now I just need some way to actually clamp that. Can't say I like this setup at all, but what's surprising here isn't that this failed miserably, it's that the end mill actually survived. I was able to get this stuck to the magnetic chuck well enough that I could take very light cuts on the grinder, and with two parallel surfaces then I could actually clamp it in the vise properly. I think if I put these two next to each other, mount that on the rails, to get this all to fit, I kind of had to slam this thing all the way up into this corner. I was kind of worried I wouldn't have room for these screws on the bottom, but it's like just enough space. It's almost like I planned it that way, which I didn't. It is hitting that screw, but that's kind of a good hard limit now. I think if I take a piece of this angle, put it on like that, it gives me a spot to put my motor. I can kind of only put the lead screw right here. For the most part, I've been kind of assuming that my stock has been square enough, but I know this one isn't, and there are enough surfaces that I need to reference off. I'm going to go through the process of doing all of it. So I had this very carefully planned out, so the holes I need to put in here would split these evenly. Except they were actually going to split these evenly. So now I need to delete that hole. This is only getting an M4 screw in it and never seeing much load, so I figure if it survives the machining, it won't be a problem in the future. Somehow I got this right this way, but it looks like these holes need to become slots. I made a shaft collar and pinned it onto the lead screw using the original through hole and pin, and then remembered that I needed to be smaller diameter, so I'll turn it down now. So now I've got another cute little Lovejoy connector on there. Obviously we can't have the motor floating in space like this, so I made a little spacer block that's reamed out to locate right over that bushing. Then the motor goes right on there. Well, we've got the CNC part of the CNC Plasma Table working. Let's move on to the plasma part. This is the Yes Welder Cut 55 DS Pro. If you saw the video I did on their TIG welder, you know I had moderately nice things to say about it. So I figured I'd give this a shot. Like the TIG welder, I paid for this with my own money, but there is a discount code and affiliate link in the description that I get a little bit of a kickback from. It's also the cheapest blowback start plasma cutter I could find. Blowback start is important for a CNC because the high frequency start ones will wreak havoc with the electronics. It doesn't have any of the connections or provisions for connecting to a CNC torch height controller, that sort of thing, but we'll see if we can use this to start on the table part of this project. I've got this old lawn tractor cart that I don't use. Seems like it'll be just about the right size. I want to put a water table on this to help contain the mess and reduce the amount of brown smoke in the shop. There's some good bar stock on here. You ever get a new tool and instantly wonder why you haven't had one before? This is one of those moments. I picked up this piece of grate from the cutoff section at the local steel yard. It's almost, but not quite ideal for this. I was planning on just stitch welding this in a few spots, but it seemed to be welding pretty well, especially for as dirty as it was, so I decided to just fully weld it. And I figured a drain would be a good idea, so I made up a little bung, put on my big boy pants, and took a shot TIG welding it in. I also added some baffles. Those should help strengthen it and might reduce the sloshing when I'm moving it around. I'm folding the end of this over just as a little guard to keep sparks off of the stuff that'll be underneath the table. I've got little to no confidence that my welds will hold water, so I sandblasted the seams and slathering them with some seam sealer. I've got one small leak right where I TIG welded that bung in. Nothing some seam sealer won't take care of. You know I wouldn't normally paint something like this, but since it's going to spend the rest of its days filled with water, I hit it with some rust converter and gave it a coat of rust encapsulating paint. This should be an interesting test to see how that paint does. This table is 3 inches longer than the travel of the machine, and I've got this little overhang here as sort of a guard for that end. So it makes sense to have the extra 3 inches on this end, which means I need to base it off of that end, which means I want to run it the whole way this way. But this screw that you can't see because it's underneath the rack is hitting here, which means I need to take it out and grind it down. But I can't get to it because it's underneath the rack. In order to take the rack off, I have to take basically everything apart. I'll bring you back in once I've got all this taken care of. One of the problems with continually adding things like this to my shop is just running out of space. I want this thing to be as self-contained as possible, and if I can eke out a little bit more storage space, that'll be a plus too. I've got this pretty well mocked up. Everything's just tacked together for now, but I've got the computer under here. I've got a drawer that a viewer gave to me, and also a spot where I can put the plasma cutter and my TIG welder, the TIG foot pedal. I'll probably add some hooks for cords here. And I've got room over here for an electronics enclosure. Pretty happy with this, so I'm going to go ahead and weld everything solid. Now, I'm under no illusion that this is anywhere close to being straight or square or even actually planar. So I've only got these held in with 2 screws here. I'm going to indicate this in, bump it around, get it parallel to the machine so that the cut height's going to stay consistent, or at least as close to consistent as I can. I'm just going to open up these holes a little bit. That definitely made it better, but not great. So I'm going to mark these holes, pull the whole thing apart, file these out, drill those other ones in. I went through and checked each of the 4 corners, and I have this as good as I can get it, which is not very because this grate isn't very flat to begin with. I think down the road the solution to this is going to be to add a torch height controller that'll adjust the height automatically, but for now we're going to run with it. Rather than weld these, I'm going to drill and bolt them. That way I can go back and change them later if I decide to. I figure it makes sense to just attach the ground for the plasma cutter directly to the grate. That way I don't have to worry about corrosion in the future. The ground cable for my TIG welder has the same connection, so if I want to use the plasma cutter handheld, I can just swap the cables. Now we just need a way to turn this thing on from the computer. This is just a GS16 aviation connector. Pretty common connector. So I just wired that up to another cable. So that comes up, goes through the E-stop, through a fuse, and to the output on the Mesa board that's configured for a spindle enable. And if you're wondering about the other 3 wires here, it's because the cable I had 5 connectors in it. So now if we give Linux CNC an M3 command to enable the spindle, nothing happens. That's because Linux CNC doesn't enable the spindle if it's at 0 RPM. So let's set a speed of 1 RPM. Why does still nothing happen? What's happening? There it goes. Obviously got a lot of cable management to do, but we can start doing some test cuts. So, looks like faster is better. Here you can see the advantage of the sort of cantilever design. Because it's open on 3 sides, I can hang a larger sheet of material over the ends. And now we're at a point where this thing can start making parts for itself. That almost worked really well, but right there I lost my X-axis. One of the Y-axis cables got pinched there and tripped the drive. So I guess cable management's probably next on the list. The cut quality's not great. Need to improve on making hexagons, because that's what you do when you have a CNC plasma cutter, but this will work pretty well. I don't have a piece of metal big enough to redo this, so I think I'm just going to weld it up and finish this by hand. I'm still pretty bad at TIG welding, but I figure welding up this electrical enclosure would be a good way to practice, so hopefully I can become less bad at it. I guess I didn't quite get the allowance for the kerf right on those. I found in sheet metal like this, I can usually get enough threads for an M3 screw to hold, and even though I had to drill out the holes a little bit, having them all located made this so much easier. I'm not going to say I made this easy on myself, but I did better than I usually do making these electrical enclosures. Let's do something about that cable management problem. The cables for the X-axis can just get tucked up and zip tied to some of the holes on this I-beam. That's pretty well out of the way. The other axes are a little more challenging, but I've got this old drive shaft that I think should help. Yeah, that'll be perfect. So this little slots in it to locate everything, goes together like this, and then that's going to be a monitor mount. Except, you know how I said at the beginning that making brackets is the process of making the wrong bracket several times? This spacing is 100 millimeters, which works out to 3.937 inches. And these holes are 3.397 inches apart. Make me another one and put hexagons on it this time. That should fit, but those definitely have 7 sides. I guess the respirator kind of muffled what I was saying a little bit. I guess that means I could finally make a wrench for that 7-sided bolt I made in the dividing head video. I probably should have left a little bit more meat around these things too, but at this point I'm kind of playing with feed rates and that sort of thing, just kind of getting it dialed in, learning it. And these are going to go on here. Got my upright drive shaft just clamped in there for now. Actually really surprised how well that fits for the first try. I think put the monitor mount on something like that. You know, one of the things that gets lost in a lot of these videos is just the sheer amount of time you spend putting something together and then taking it apart, and then putting it together and then taking it apart. I don't know that taking the electronics off of here is super necessary since I'm, running the plasma cutter through all of this, but I figure it's not going to hurt anything if I do. Probably better safe than sorry. Well, I like that. Now what I can do is take my cords, drop them down here. Except they don't reach, and I don't really want them rubbing against that sharp edge. I'll have to get some longer cords, but I can do something about that. It turns out that every once in a while bungee cords and zip ties are actually the proper solution to your problems. Figured I would check the backlash and set the backlash compensation. I don't know that there's really enough to worry about. That's also probably about the worst spot on the lead screw. Yeah, maybe we'll do something on that one. Of course, if I come out closer to the end, I'm basically getting nothing. I think it also has something to do with how this little spring on the gear is engaging. I think I'm just going to leave it alone for now. I tried slowing down the feed rate on the smaller features on this one. The design of the machine does lead to it bouncing around a little bit under high acceleration, so running slower seemed to clean up the quality a good bit. I should also start programming lead-ins to the cuts, since where it pierces it blows the hole a little bit wider. These little filter screens might do something to keep dirt, or at least small rodents, out of the electronics. And I think that just about buttons up a pretty epic project. I'm really looking forward to putting this thing to use, learning its quirks, upgrading it. I think it'll change the way I do a lot of things, mostly making brackets. But before I say thanks for watching, we should give it a name. Scrap Droid 0,000. Thanks for watching.